Hi students, welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall continue our discussion of trigonometry. In this video, we shall discuss the unit circle, and this will be part 1. So I want to make the video short, so that's why we shall have part 2 as well. Please, before you continue with this video, it is highly recommended that you do this. You go to, when you log into my website, on trigonometry, if you go to trigonometry, it is a playlist on trigonometry. It is highly recommended that you view those videos in order. Okay, if you want a good understanding of this, you need to view the videos in the playlist on trigonometry in order. Very important. Let's talk about the unit circle. When we talk of the unit circle, we are talking of a circle of radius 1 unit. So when we talk of the unit circle, we mean a circle of radius 1 unit. This is the center of the circle. The center is at the origin, okay? Radius of 1 unit. That's the unit circle, right? A unit circle is a circle of radius 1 unit. That's the unit circle. You can recall, if you recall, what is the equation of a circle? What is the equation of a circle at center? Equation of a circle with center AB. What is the equation of a circle? Equation of a circle with center AB. If you recall this, it will be what? X minus A all squared plus Y minus B all squared equal to R squared. And of course, R is the radius. R is the radius. So this is the equation of a circle. You did this in algebra. You did it in algebra. Now, when we have a circle center at the origin, if the center is at the origin, if the center is at the origin, right? That means it is what? 0, 0. Just like you have here, 0, 0. Then, equation of the circle will be what? The equation of the circle, will be x, of course, minus 0 all squared plus y minus 0 all squared equal to r squared. So this means that it will be x squared plus y squared equal to r squared. So this will be the equation of the circle center. Now, for this unit circle that we are going to study, we are looking at a circle center origin radius 1 unit. So, and this is the equation of that circle right here. Okay, now let us now talk about special angles. Let us talk about special angles. And what do we mean by special angles? Special angles are the multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? Multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? Those are special angles. One nice property, one nice characteristic, one good feature of special angles is that you can compute the trigonometric functions of these angles without using a calculator. You can compute, you can find, you can determine the trigonometric functions of special angles without a calculator. Okay, now we will do some of them in this video. Please, before I continue, I talked about trigonometric functions, so it's in that playlist. So it is recommended that you have viewed trigonometric functions. And for the trigonometric functions, recall for the trigonometric functions, we had so, ka, twa. And we also had cosec, ho, sec, ha, cotan, ao. Okay, now we did this in this previous video. All right, we are going to compute the trigonometric functions of these angles without a calculator. For this video, we shall start with quadrantal angles. Let us start with quadrantal angles. Now, but before we do quadrantal angles, we want to do something now. Okay? Consider, or say you have an angle theta. Please, I will use Greek alphabets for angles. Say you have an angle theta drawn in standard position. Okay? That intersects a circle. That intersects a circle whose terminal side intersects a circle at a point P. An angle theta drawn in standard position whose terminal side intersects a circle at point P. Okay? Whose terminal side intersects a circle at point P. Now, let us visualize what I just explained. So you have the circle. You have the circle here. And you have this angle here, say theta. Say you have this angle theta intersecting this, whose terminal side is drawn in standard position which means from the initial side. The initial side is the positive x-axis, whose terminal sides intersects this circle, okay, at point P, x, y. These are the coordinates of the point P. So that tells you that the point P is on the circumference of the circle. Point P is on the circumference of the circle. Right? Now, let's make a triangle here. If we have a triangle here, if we draw a right triangle here, this will be our y and this will be our x. That will be our y, which is the vertical, and the x is the horizontal. Alright, now let's go ahead and let us define the 6 trigonometric functions based on this. Let's define it. The 6 trigonometric functions based on that diagram. If we do that, what do we have? We have that sine theta will be what? Opposite over hypotenuse. Now this is still r, radius r. Okay, radius r intersects a circle of radius r. Please put intersects a circle of radius r, small r. Then at point P, So sine theta will be opposite over hypotenuse, which is y over r. Then cos theta will be adjacent over hypotenuse, which is x over r. Tan theta will be opposite over adjacent, which is y over x. Now let's go to cosec. Cosec theta will be 1 over sine theta, or you could say hypotenuse over opposite, which is what? R over y. And we did this in the previous video. Sec theta will be r over x, and then cotan theta will be x over y. Now, let us apply this definition to a unit circle. Applying these definitions to a unit circle. Okay, remember that unit circle has radius r equal to 1. Okay, applying these definitions to a unit circle. Of course, unit circle means that radius is 1 unit. R is 1 unit. So what if we do that? What we're gonna have? We will now have that, and this is for unit circle only. Unit circle only. We will now have that sine theta is equal to y over 1. So this implies that sine theta is equal to y. Cos theta will be x over 1. This implies that cos theta is equal to x. Tan theta will still be what? Y over x. Cosec theta will be 1 over y. Sec theta will be 1 over x. And then cotan theta Cosine theta will be x over y. Alright, folks, this is what we need. This is what we need. And we will now get started right away. So now, let us draw a circle. Okay? You know, this is freehand. Alright, I'm going to divide this circle into 4 quadrants. Now, like I said, we will start with our quadrantal angles. We will find our quadrantal angles first. So, the center of the circle, as usual, is at the origin, 0, 0. And of course, the radius is the distance from the center of the circle to the circumference, any point of the circumference. That's what we define as radius. So this is 1, 1, 1, you know, this is 1. This is going to be 1. This is going to be 1. This will be 1. But you know, it's negative 1, negative x in the quadrant. And then this is negative 1 for y. But this is 1, 1, 1, 1, 1, 1. Okay? It's 1, 1, 1, 1. Is the radius. Now, this is the 0 degrees. Okay? And this is 90 degrees. 90 degrees. Let me extend this here. This is 180 degrees. This is 270 degrees. 270 degrees. And this will be 360 degrees. 360 degrees. Okay? Let's write their coordinates. Let's go ahead and write their coordinates. Let me use another chalk to write their coordinates. I hope you see this chalk. Of course, the coordinates of this is what? 1 and 0. This is also 1 and 0. Right? The coordinates of this is what? The coordinates of this is 0 and 1. 0 and 1. And this means x, y. Okay? This is x, this is y, of course. Coordinates, x, y. This is x, this is y. You know, in coordinate, a point has a coordinate. The coordinate, the first coordinate is x coordinate, and the second coordinate is y coordinate. Then this will be what now, folks? This will be x is negative 1 and 0 here. And of course, this is x, y. Then here, 270 degrees, x is 0 and y is negative 1. 0, negative 1. This is x, y. So these are the coordinates. Our quadrantal angles, you know, our quadrantal angles, they lie on either the x-axis or the y-axis. The next thing here, let's go ahead, the next thing here we want to do, let's go ahead and write the radians right away. Let's write their radian measure right away, so we won't have to spend time doing that one separately. Now we know that a complete revolution is 360 degrees or 2 pi, right? 360 degrees or 2 pi. So this is 2 pi, and half of it is going to be pi, 180 degrees. Of course, 0 will still be 0 anyway. Then one quarter of it, one quarter of the revolution is 90 degrees, or is pi over 2. That's 1 over 4 times 2 pi, which is pi over 2, right? And then 3/4 of it, 3/4 of it will be what? 3 over 2 pi. Does it make 3 quarters of it will be 3 over 2 pi, because 2 divided 4 is 2. So 2 divided 180 is still 90. 90 times 3, 270. Yeah. So you just kind of know this, you know, half, add half, you can just have a trick for remembering it. If you add half, is pi over 2 here. Add half again is pi. Add half again is 3 pi over 2. Add half pi again. You should be adding half pi, not just half. Half pi. Half pi. If you add half pi, add half pi, pi, add half pi, 3 pi over 2. Add half pi, 4 pi over 2, which is 2 pi. So it makes it easy for us. We don't have to come and start writing it again. Okay, now let us, that is a trick to remember it. Now let us, this is for quadrantal angles, so we are still working on quadrantal angles. Let us write this so it's easier for us. Let's write it out here. For unit circle, is for unit circle only. We see that sine theta is y, cos theta is x, tan theta is y over x, cosec theta is 1 over y, sec theta is 1 over x, and then cotan theta is x over y. Okay? Sine over cos, tan, cos over sine, cotan. We talked about it in the previous video. Alright folks, let us now begin our work. Let us now do what? Begin our work. We have been talking a lot. Let us now do the work. So I'm going to try to write this to fit in. I'll try to write it to fit in. Okay. Let us write it to fit in. Now we will have angle theta, let's say theta in degrees, DEG. Let's say theta in radian, RAD. You see this in your calculator. Degree, radians, and gradients, DRG. Degree, radians, and gradients. But we are not dealing with gradients. Then let us write our sine theta. Sine theta. Cos theta. Tan theta. Cosec theta. Sec theta. And then cotan theta. Cotan theta. Okay. I'm going to draw this with double lines to demarcate it. Alright, 0 degree, 0 degree, 0, let's just write 0. 0 is still 0 in radian. Sine 0. Sine 0. Remember that sine theta is y. Sine theta is y. And this is y. You see, that's why I put xy. So sine 0 will give you what? 0. 0. Because sine theta is y. Cos 0. Cos theta is x. So cos 0 is what? 1. Tan 0 is y over x. So 0 over 1. 0 divided by 1. 0 divided by 1 is what? 0. Right? So tan 0 will be 0. Y over x. Cosec 0 is 1 over y. Cosec 0 is 1 over y. Cosec 0 is 1 over 0. And 1 over 0 is what? Undefined. So this is undefined. You write undefined. Sec 0 is 1 over x, which is 1 over 1, which is what? 1. 1 divided by 1 is 1. Now, cosine 0 is x over y. It will be 1 divided by 0 also. 1 divided by 0, and that is what? Undefined. And guess what? You can always check this out with your calculator. It should work. Okay? If you check it out with your calculator, it should work. Now let's check it again to make sure 1 over 0 is undefined, and then x 1 over 0 is undefined. I mean, that's the way you do it. Now if you want to do cotan as 1 over tan, you know, some people might say cotan as 1 over tan, right? And tan is already 0. So they will say 1 over 0 to still be undefined. But I want to tell you something. I want to tell you something now. You have to be careful. Cotan is a little bit tricky. Cotan, you know, is 1 over tan. Okay, cotan theta is 1 over tan theta, or cos theta over sine theta. Okay, and it's also x over y because of this unit circle. We are going to consider both cases. We are going to be considering both cases. Okay, if we consider x over y, it's going to give us undefined. We consider 1 over tan 0, it still gives us undefined. Then we are good. Just know that we will consider both cases, because as we move on, you will see what I'm talking about as we move on. Now the next one we do is 90 degrees. What is 90 degrees? Is pi over 2 radians. Sine 90 is y, which is 1. Sine 90 is 1. Cos 90 is x, which is what? 0. Tan 90 is 1 divided by 0, which is undefined. Cosec 90 is 1 over y. Cosec 90, 1 over 1, which is 1. Sec 90 is 1 over x, 1 over 0, which is what? Undefined. Now, cotan 90, let's do it x over y. It will be 0 divided by 1. Okay? If cotan 90, if we do it x over y, it will be 0 divided by 1, which is 0. But guess what? If we do it 1 over tan 90, you see what I'm talking about now? Cosec 90 is what? Cotan, not cosec. My bad. Cotan 90 degrees is what? X over y, which is 0 over 1, which is 0. Now, so if you say cotan 90 degrees to be 1 over tan 90 degrees, right? You will have 1 over undefined. 1 over undefined. And we don't, no, that is not, this is wrong. We have this 0. So, like I said, you have to consider both cases. Both cases before you just write the value. The next one is what? 180 degrees. 180 is what? Pi radians. Sine 180 is what? 0, because is y. Y is 0. Cos 180 is what? X, negative 1. Tan 180 is y over x, which is 0 over negative 1, which is 0. Cosec 180 Cosec 180 is cosec 180 is 1 over y, which is 1 over 0, which is undefined. Undefined. Sec 180 is 1 over x, which is 1 over negative 1, which is negative 1. Right? And then cotan 180. Cotan 180 is x over y. So if we do x over y, we have negative 1 over 0. It is undefined. If we also do 1 over tan 180, it will be 1 over 0, right? Which is still undefined. So we say it's undefined. Undefined. You see that? Now the next one is what? 270 degrees. And 270 is what? 3 pi over 2. 3 pi over 2. Sine 270 is y. Okay? Sine 270 is what? Y. Which is what? Negative 1. Cos 270 is x, which is 0. Tan 270 is y over x. Negative 1 over 0, which is undefined. Cosec 270 is 1 over y. 1 over y. 1 over negative 1 is what? Negative 1. Sec 270 is 1 over x. And that gives us undefined. Now, cotan 270, x over y. So 0 divided by negative 1, which is 0. Okay, but if we do it 1 over tan 270, you see, if we did it 1 over tan 270, if we did cotan 270 as 1 over tan 270, it won't work because you can't have 1 divided by undefined. Okay, so it wouldn't have worked. So we have to do it x over y, which is 0. And you see how this is, if you study these patterns, you see it's like how this is undefined, 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 undefined. Okay, the next one, the last quadrantal angle we have here is what? 360. 360. 360 is 2 pi radians. Sine 360 is what? Sine 360 is y, which is 0. Of course, 360 will have the same thing as 0 anyway. Because 360 is 1. Tan 360 is y over x, which is 0. Cosec 360 is 1 over y, which is undefined. You see the patterns. You see how the pattern is going. Sec 360 is 1 over x, which is 1. And then cotan 360 is x over y, which is undefined. Or 1 over 0 here, which is still undefined. The same thing as 0. The same thing as 0. They are coterminal. 0 and 360 are coterminal. That's why you have it that way. We did coterminal angles. Please view the video. Alright. I really want to do something. I really want to work on the first quadrant before I stop this at 1. I don't know how many minutes I have spent already. But I really want us to talk about 30, 60, 30, 45, 60. Also in this part 1. Now remember, this is your first quadrant, second quadrant, third quadrant, and fourth quadrant. Remember that? We discussed that before. And of course, we say that this is asked C. I'm going to use another color. Asked C. Asked C. Or you can say cast, depending on the way you want to move. Some people say acts. Some people say cast. Some people say ASC. Somebody like me, I say ASC. We talked about this before, so we won't waste our time on it. Now, let us find, we have found that of the quadrantal, the trig functions of the quadrantal angles. We are now going to find that of the first quadrant, 30, 45, 60. Then we can, continue with the rest in part 2. Okay, folks, I will need to erase this. Let me erase this first and try to use this here. Now, in your recall in the theorem on 30 degree, 60 degree, 90 degree triangle. Theorem on that. Recall that. I'm gonna use here to illustrate this. Oh, I erased this unicycle. I needed it, honestly. Well, I'm gonna we are going to write it again. We'll write it again. That's not a problem. Yeah, let's go ahead and write it again. We know that sine theta is y. We know that cos theta is x. We know that tan theta is y over x, right? We know that cosec theta is 1 over y. We know that sec theta is 1 over x. And we know that cotan theta is x over y. Yeah, please, this is very important that you know. Okay, folks, look up. I want you to look up. So let's draw another unit circle. Let's have this. This is still at the origin. And we want 30 degrees. We want an angle of 30 degrees. Okay? Let's draw a right triangle here. And if we draw a right triangle here, from the, the theorem on triangles, one of the triangle theorems, the sum of angles of a triangle is 180 degrees. This is 90 degrees, this is 30 degrees, so this will be what? 60 degrees. And this is still our R, and we know that our R is 1. And this is our Y, and this is our X. Right? See that? Okay, now look up. In our theorem on 30, 60, 90, this is a 30, 60, 90 degrees. 30, 60, 90 degrees. Okay? We see that the hypotenuse, okay, the length of the hypotenuse is equal to 2 times the length of the shorter leg. Length of shorter leg. These are the legs. The Y and the X are the legs of the Y and the X are the legs of the triangle. So length of the hypotenuse is 2 times the length of shorter leg. This is a theorem. Okay? It's a theorem. And you need to take it down. So you know it. Length of the hypotenuse is 2 times length of shorter leg, and then length of longer leg is equal to square root of 3 times length of shorter leg. length of shorter leg. Okay? So this is what we are saying here, folks. Look up. This is what we are saying. This is a 30, 60, 90 equation. R is the hypotenuse. You know, if you view the video I did on the Pythagorean theorem, R is the hypotenuse, X is the longer leg here, and Y is the shorter leg. Okay? X is the longer leg and Y is the shorter leg. So in this case, because in this case, R hypotenuse, X is longer leg, Y is shorter leg. So hypotenuse R is equal to 2 times what? Shorter leg Y. 2 times Y. See that? So now, but remember that our R is what? 1. Remember that our R is 1 because it's a unit circle. So 1 is equal to 2Y. So 2Y is equal to what? 1. Therefore, Y is equal to 1 over 2. What am I trying to do? Because we got these quadrantal angles, we just got their coordinates. When we got their coordinates, we were able to get their trigonometric functions. So if we could get the coordinates of all the other special angles, we are done. Because once we get the coordinates, this is their trigonometric function. So what I am trying to do is, this is 30 degrees here, this is 30 degrees here. I am trying to just find X and Y. That is what I'm trying to find. That is what I am trying to find. X and Y. Once you can start getting all the coordinates, it makes it easy for the unit circle. So our Y is 1/2. That is the first part of the theorem. The next one is length of longer leg is square root of 3 times length of shorter leg. So in this case, our longer leg is X is equal to square root of 3 times what? Length of shorter leg, which is times Y. So X will be what? Square root of 3 times 1 over 2. So X is what? Square root of 3 over 2. You see that? So this means that our 30 degree now will be root 3 over 2 and what? 1 over 2. That is it for 30 degrees. So if we come here, folks, if we come here and put 30 degrees, if we come here and put 30 degrees, yeah, what are we going to have? 30 degrees is what now? What will it be in radians? This is pi over 6. And you ask me, Mr. C, how do you get this? Come on. What will you do to 180 to give you 30? What number? Because 180 is pi. 180 is pi. So what are you going to multiply by 180 or divide by 180 to give you 30 degrees? You have to be able to be easy to convert between degree and radians. Just say pi is 180 degrees. So if you want to find any other thing, you can use 180. What am I going to do to 180 to give me 30? I divide by 6. So that means this is pi over 6. That is what it means. Pi over 6. Okay? Then sine 30. Sine 30 degrees. Sine 30 degrees is going to be what? What will it be? It will be y. Remember, sine theta is y. So our y is what? 1 over 2. So this will be 1 over 2. 1 over 2. Then cos 30 degrees is what? X. Root 3 over 2. This is root 3 over 2. You see that? 1, 2, 3, 4, 5, 6. Tan 30 degrees is y over x. Let's calculate it. Tan 30 degrees is y over x. Tan 30 degrees is y over x. So this is 1 over 2 divided by root 3 over 2, which is what? 1 over 2 times 2 over root 3. 1 over 2 times 2 over root 3. So that is what? 1 over root 3. Okay, you have that 30 degrees 1 over root 3, folks. But you don't want to, you want to, what is 1 over root 3? Rationalize it. Rationalize it. So this is times root 3 over root 3. And that is what? Root 3 over 3. So tan 30 is root 3 over 3. You come here and write root 3 over 3. Okay? Cosec 30. Cosec 30 is 1 over y. So that is 1 divided by 1 over 2. 1 divided by 1 over 2 is what? 1 divided by 1 over 2 is what? 1 times 2 over 1, which is 2. Cosec 30 is 2. Sec 30 is 1 over x, which is 1 divided by what? 1 divided by root 3 over 2 is what? 2 over root 3. Now you have to convert this, you have to rationalize it, rationalize is the nice word, rationalize. So times root 3 over root 3, and that is what? 2 root 3 over 3. So this is what? 2 root 3 over 3. And then cotangent 30 will be what? X over y. So x over y will be root 3 over 2 divided by what? 1 over 2, which is root 3 over 2 times 2 over 1. Bam, bam, which is what? Root 3. Okay. I am kind of scared that this video is getting long. So why don't we just stop here for part 1, and part 2, I will just have to write this 30 degrees up here, and then I will have space for the next one. So just stay tuned for part 2. Okay? Stay tuned for part 2. Thank you so much for listening, students.